So this is question 15 from the mixed exercise, and a few people have asked about this, so I'm going to go through this step by step. Okay, so the first thing to say is that we need obviously to read the question carefully. So looking at this, it says the archer hits a bullseye with probability 0.6. She shoots 20 arrows at a time. So this is definitely a binomial distribution because we've got a fixed number of trials, fixed success. So let's write that out. And what we're going to say is that X is the number of times that the archer hits the bullseye. So that's our variable. And this random variable X is distributed binomially. Number of trials is 20. Probability of success is 0.6. Now, part D of this question, it doesn't, but part D of this question might have said, is there a reason why this might not be binomial? And if that does happen, then, an archer probably would get better the more shots that they had. So you would say something about the trials probably not, the probability probably not being constant because you'd expect them to improve the more practice they had. Okay, let's get back to this one though. So part A, I think this part probably most of you could have a good go at, but let's write it out just to be sure. So part A says, find the probability that X is at least 50%, so at least greater than or equal to 50% 10, so more than or equal to greater than or equal to 10 times. For our binomial on our calculators, it can only do less than or equal to, so let's make sure that we're changing this and we know what's going on here. So let's just stick a few numbers down on our number line. I want greater than or equal to 10, so I want 10 included in the part that I want. So this is the section that I want. So I'm going to need to do 1 minus this bit here that I don't want. So this is equal to 1 minus the probability of X being less than or equal to 9. Okay. So now I'm going to get my calculator, and this is definitely binomial CD because it's less than or equal to here. So I'm just going to get my calculator and let's do that. Okay, so I need to be in my probability distributions, then I need to be binomial CD because it's less than or equal to. I know my variable value, so I'm going to go for a variable rather than typing in a load of them. I know the value I want is 9, so variable, I'm going to go for 9, and then my N is 20, my probability of success is 0.6. Okay, and so that is going to give me 1 minus 0.12752, etc. Now, just to remind people about how you can store things in your calculator, so you can go back to the normal calculator mode and manipulate this with a few values. This store button here, we can store the value that we want, the answer that we've got, into any of these letters. I don't know if you can see from there, but little pink letters A, B, C. So I'm going to go store, and I'm going to put that stored to A, and then when I come out of here, go into my normal calculator, I can now do 1 minus, I want A, so it's a letter alpha A, and that'll do that for me. And that's quite useful if you've got more than one value that you want to keep from your statistics functions. So our answer here, 0.8725 to 4dp, or 0.872 to 3SF. Obviously, anything that you've rounded is fine. Make sure you give a fuller answer first before you do your rounding to ensure that you're going to get that answer. Okay, so that's the first bit done. Part B now, before we do this, we need to have a think about what's happening here. She then shoots 12 sets of these 20 arrows. So it's this 12 sets now that we're interested in. That's going to be our number of trials. Okay, so find the probability that he hits the bullseye with at least 50% of arrows. That's this probability. This is the probability of that happening every time. So that probability, all of that sort of sentence, is just encapsulated in this. And then we want the probability of this being equal to 7. Okay, so it's the 12 now that's going to be our new number of trials. Okay, and what I'm going to do here is I'm going to use a different letter, let's say capital Y, and that's going to be the number of sets of these 12 that she hits the bullseye with at least 50% of arrows. Okay, and if I do that, if that's my new random variable, well then now this Y is binomially distributed. She either does this or she doesn't. So binomial distributed, she's doing 12 sets of this, so 12 trials, and the probability of success now is this, because this is the probability of hitting the target at least 50% of the times. So this, sorry, hitting the bullseye. So this is my probability of success that goes in here. And luckily now I've got that stored as A in my calculator, so I won't need to keep typing that in. I can just use A on my calculator. Okay, so let's keep going with this. So this, I'm just going to remind myself I've stored that to A. So let's have a look at part B. Find the probability she hits the bullseye with at least 50% of her arrows. So all of that is just this probability of success. So find the probability she is successful 7 out of 12 times. So I want 7 of these 12 to be successful. So I want y to equal to 7. Okay. Now because it's equals and not less than, this is going to be the binomial probability distribution function, the PD on our calculator, not the CD that gives me less than or equal to. So straight then on my calculator, let's go back and start from scratch. I want binomial PD this time. Again, a variable because I know the value that I want. So that's 7. My n is now 12. And my probability, I don't have to type all this in. You can if you want to, but if I've stored it, I can now go, okay, I know it's stored in A. So in there, I'm going to put alpha A, and you'll see it's actually put that value in. I've realised now that I've done that wrong, so I'm going to go back. Excuse me for 1 second. Let's go back to 1. What I needed to do actually was do my answer to that. This is the answer I want. I should have stored that, so let's do that now. Store that to B, and now B is what I want as this value, 0.87, etc. Okay, so let's try that again. So binomial PD, variable is 7, n is 12, and now hopefully my probability of success is this value, which is my value of B. Yeah, and there it is. So my answer, there we go, 0.01027, etc. So 0.0103 to 4dp, 0.010 to 3SF, 0.01 to 2dp. As long as you've given this fuller answer, then if they're not saying what accuracy to give it to, this will get you the marks as long as you've rounded this correctly to whatever you fancy. Okay, last part of this then, I'm just going to get another piece of paper. So the last part of this question now, find the probability she hits the bullseye. All of this is just our previous probability of success here. So find the probability that she hits the bullseye with fewer than 6. So not at least, not less than or equal to, fewer, so less than 6 here. I can see what I've done there. That should be a y. Let's get that for completeness. So the probability that y is less than 6. Let's think about our number line. A couple of seconds just to make sure I'm getting this right. So for my binomial CD on my calculator, it only does less than or equal to, so I've got to change this to a less than or equal to. So I want less than 6, so I don't want 6, I want everything less than that. So that's the same as the probability of y being less than or equal to 5. And now this is definitely a binomial CD cumulative distribution because it's all the way up to and including 5. It's not just equal to 5, it's less than or equal to 5. So binomial CD on our calculators. Let's do that. So down one, binomial CD, variable because I know my value of y. This time I want it to be less than or equal to 5. It's remembered the distribution, and there we go, quite a small number. Don't know if you can see that on the screen, but I'll write it out. So it's 2.4, etc., times 10 to the minus 4, so 0.0002499, etc., and that's 0.0002 to 4dp, or 24 to 2SF. It's, again, as long as we've got this, this is absolutely fine. Okay, I hope that's helpful. Take care.